Okay, welcome to today's webinar where we're going to be presenting the slides that we're going to share at the upcoming Northeast Decision Sciences Institute conference in Philadelphia on Friday this week. So thanks for joining us. So this is about spine programming theory, and we wrote a research paper together, myself, Benjamin Branch, and Denis Poussard. And spine programming theory is a form of on-device, local, sovereign AI code indexing and code generation. A watcher service runs locally to watch a project directory for code files created and modified, and parses code files and code comments as changes occur. Spine programming development, code indexing, and code generation lets developers focus on business logic, allowing APIs, pages, access control, and database to be AI generated. On average, spine programmers write 2% to 4% of code by hand, and the other 96% to 98% of the code is AI generated, resulting in 33 to 50 times faster software development. Here's some of the keywords of our article. So spine programming theory already has several different application domains where it's been deployed, like data-driven websites, public data updated by admins like trailblazehunt.com. This is the oldest example of spine programming theory, built 20 years ago, and it's still running today. And then smart aquaculture, smart agriculture, and smart city digital twins provide regional data sovereignty for global projects with internationalization, like the smart aquaculture site at smac.computate.org. And then several social innovation and racial equity sites have been built as public data call to action reporting for inequity. And we've developed solutions like Open Data Policing North Carolina and racial equity report cards at these two sites, Open Data Policing NC.com and racial equity and rerc.southerncoalition.org. And then another site that is available is AI telemetry in the Mass Open Cloud. And it's about cloud observability and data center management for multi-level, multi-tenant access control to cloud resources with zero trust, and dashboards and metrics to analyze cloud resources and infrastructure. And then build your own brand websites like computate.org provide software as a service websites for granting access to your solutions or products. So how it works under the hood is there's this Java service called java.nio.file.watch service that brings event-driven spine programming theory to life. So it's open source. All the components of SPT are open source, and it also includes an Apache Zookeeper cluster manager that provides file locking to prevent multiple saves from being generated twice at the same time and potentially making a file incomplete because if two processes were trying to save the file at the same time. And an Apache Solr search engine to store the data model, which is storing the complete code index of local code parts as they are created or modified in your code project, in your spine program. And the SPT event-driven watcher service parses code with introspection into the code comments, and it indexes and generates code based on the code comments. So you can generate Java models and Java APIs and database schemas and open API specifications, HTML web page Jinja templates, and API-driven JavaScript, all from describing what you want, and then the SPT Watcher service generates all the code for you. Oh, I'll practice going through the slides the way it's supposed to be. So this is an image, a screenshot of the original trailblazehunting.com site built with SPT, the earliest version 20 years ago. And if you look on the left, it says about us, outfitters, vouchers, landowner tags, wildlife divisions. These were the first data models built with SPT because the admins needed a way to add outfitters and vouchers and landowner tags on demand. So I built each section as individual data models to update over time. And then this is one of my favorite examples of SPT, the former Little Orchard Preschool.us enrollment site from 2017 to 2021. Back then, my kid was going to preschool at the school, and we went on a field trip to a pizza place. And I was sitting down with the owner of the preschool and talking about how I was a computer programmer. And she told me, when it would be so great to have a website where parents could enroll their kids into a class and then I could manage it online and they could pay for their um, they could pay for their child to go to school. And I thought that was such a great idea to build with spine programming theory that I accepted the challenge and 6 months later launched the new Little Orchard Preschool.us site, and they were able to download the enrollment forms or submit the enrollment forms online. And it was an online form, and they could put in all the information, and then it would reserve a spot in a class for their child, and then links to make payments. So this, when I told the owner of the preschool that it was done, I also said, by the way, if you want to open new locations of your preschool, the website can handle it because it handles multiple locations, not just your location in Bountiful. And she laughed at me. But 1 year later, she called me up and said, hey, Chris, how do I turn on a new location because I'm launching a new preschool in Farmington, Utah? And that was really exciting because the next year after that, she launched another preschool in Kaysville. And then after that, it was the pandemic and she organized an online preschool as a separate school. So then she was able to sell her business, and the other owner, the new owners used it for a couple of years, but eventually used their own software. So, but this is the value of spine programming, to build solutions for your own ideas. And it's based on these principles. So code indexing means you write code and then you need to parse it and index it, which is what the SPT Watcher service does, and then start generating code based on what you know about your code base. And because you've indexed it, it can actually figure out relationships between codes, because sometimes code files point to each other and you need to be able to resolve those relations to make the right import to access different models and APIs that relate to each other. And then you also have to set up a declarative order of constraints, because each code model has an order to it as it should appear in your website. Like you might list data models in order, or you might group them into detailed sections that kind of group them in a logical way. And then when you create a database schema, there's an important order that's required, that you want to declare models that have no relationships first. And then when you have relationships between database tables, you need to, we declare all of those at the end, but there's still kind of an inherent order that you want to follow, where you create one model and then the next model, and you can define all that with orders of constraints. And and then the open API spec that's generated follows the same order. So you want to avoid conflicts in your code where the order changes based on however the search engine is feeling on displaying the results randomly, because then you end up with a lot of conflicts over time when you're merging code for a collaborative project. And you can model business challenges like the ones I described for Little Arch Preschool. And then you can add zero trust, fine-grained access control, and multi-tenancy, because this conference we're doing right now is a lot about security. And so we're going to show some examples of zero trust, fine-grained access control, and multi-tenancy here. So this is AI telemetry in the Mass Open Cloud, which features a ton of examples of multi-tenancy and fine-grained access control. And why do we have AI telemetry? Because companies are scaling AI in a way that increases both compute and energy at the same time. SBT gives companies a system where cost, energy, and performance are continually optimized instead of compounding, like this AI telemetry developed by Red Hat Research and the Mass Open Cloud. So proprietary agentic AI has a growing dependency on external infrastructure, unsustainable energy, rapidly increasing token costs, rising security, and data exposure risks. So the advantages of SBT are local and sovereign, that reduces the need for external AI. And then it also reduces energy consumption and reduces long-term compute costs because we're not using GPUs with SBT, just the power of your own computer without GPUs. And it's open source. There's no tokens to use SBT like there is with traditional AI, like ChatGPT, Claude Code, etc. And it builds the system and monitors it and optimizes continuously. And SBT provides zero trust, fine-grained access control, and multi-tenancy, protecting against rising security and data exposure risks of AI, full data ownership and security, custom authorization scopes. For example, if you need to support public data, internal, confidential, or restricted data, you can give data different scopes and assign roles, groups, and permissions to gain access or to grant access at these different scopes. And then SBT changes the cost structure of software development, how software is built, how it runs, how much compute it uses, how much energy it consumes, and decreases the cost significantly while maintaining full control of your data and code. So, so in AI telemetry, we can have a tenant like this NAIR, which relates to National Science Foundation projects, and they can have their own dashboard for their own projects to see if pods are terminating, or there's different alerts in this system to show them if there's any problems or if everything's looking good, and they can see dashboards to see how their GPU utilization is doing, for example. And in this way, we model your energy infrastructure and operational systems as a digital twin, allowing you to see where cost is being wasted and optimize it in real time with developer workbenches in your own sovereign cloud environment, like we do in the Mass Open Cloud for AI telemetry. So event-driven digital twins for supply chain scenarios are another example. Now, this is what spine programming looks like on the left here. It's a code comment for a Java class, and we describe the order of constraints here. We give it a description. It supports multiple languages, so you can describe your model in multiple languages and give it a name and an icon and the number of rows you want to show when you query this data model fishing boat. So we show 100 by default, and some how it should appear on the map, and the URL when searching for a fishing boat, the URL when editing a fishing boat, and the API to access fishing boats as JSON data. And then here with the API methods, we're providing a search page in French and English. although this one's a little out of date. And then an edit page in French and English, and then other APIs to search, get, patch, post, delete, and import data. And then we provide authorization groups. This is the fine-grained access control permissions where we create a fishing boat viewer that has read-only access and a fishing boat editor that can post and patch resources as well. So this is an example of our digital twin simulation where we can simulate boats going around a path on a map with GIS data, paths, GeoJSON type data, and we can turn that on and off, and we can change the speed of the boat to increase its loop around the ocean. So in this way, we have smart aquaculture digital twin simulations, and we have smart agriculture digital twins for farms like South Norwood Farms in Ghana, and developer computer management for cost-effective data center automation. And we showed the multi-tenancy, zero trust, fine-grained access control, how it's configured in the spine programming code, and that'll protect against rising security and data exposure risks. And then think about data sovereignty with international language translations for global supply chains with SBT for a minute, because we can separate the data. We can provide one smart aquaculture platform that serves multiple regions, and we can keep those regions separate so they don't see each other's data or collide in any way. And we can also provide interfaces in both English on the left and French on the right, so you have a consistent experience no matter what language you're in and what region you're in. And then here's another application that we've built for supply chain data center management, demonstrating installing applications using self-healing event-driven playbooks on computers. So you define a tenant to keep different organizations from accessing each other's data. And then you create host credentials to your computers so that you can run some automation by connecting with SSH, and then set up an Ansible project, which is meant to contain automation code as YAML from GitHub, and then a job template to install to run some automation, and then configure your computers as hosts with IP addresses and fully qualified domain names. And then you can create host checks, and you check for a condition like a certain file existing. And if it doesn't exist, then data center management will go and as an agent, it'll check on the host if that exists. And if it doesn't, it'll run some Ansible automation to install the application. So we use open source Fireware smart data models to model smart cities, smart agriculture, smart aquaculture, and environmental data, like we've done in our digital twin platforms. And together with spine programming, intelligent code indexing, and code generation, a repository of useful data models can be indexed into a search engine and rapidly built into a data-driven website and API to address the needs of communities following the smart data model standards. And we have a ton of education available at spineprogramming.com for universities and individuals who want to learn more, career path builder opportunities, enterprise open source cloud application development experience. We've done so many hackathons for social good, like this one with Shaw University, focused on domain digital twins. And here was another hackathon with 3 universities in North Carolina, focusing on fine-grained access control, built on OpenID Connect, authentication and authorization, and smart data models. And this can help develop open source program offices for sustainable open source software development at universities. And what does SPINE stand for again? It stands for Spine Programming is Not Easy, because of the level of knowledge required to become a spine programmer, but that's why I wrote this research paper is so that you can learn how to solve problems in neat expressions, because software programming is never ending. And companies that do not restructure how they deploy AI and manage energy will face escalating costs and reduced control. Teams that adopt SBT will gain a structural advantage in both cost and operational sovereignty. So we're your SBT experts for cost and control, architects for the AI era. And feel free to learn more at spineprogramming.com. Okay,